that topic. Okay. When we say real numbers, what do they mean? Or what does it mean rather? So we talked about real numbers in the last class. This is a real number. So what does it mean? Who can remember? Should I call our names real numbers? Was there anybody here when we did the real number? And I think I'll share the link to the replay. So even if you are not here, you will have watched the recordings. Okay, let me call Miss Adejoke. Mrs. Adejoke, did you do you remember?
Good afternoon. I wasn't in the class and I have not had time to play. I wasn't in the class and I've not even had time to play it and listen to the class as well.
Okay, no problem. Who was in the class? All right, Mr. Israel, you were in the class on that day. Tell us, what did we say real numbers are? Yes, you're live. That is why I said that we should always be having feedback on these classes. After the class, let's keep interacting, going back and forth on what we have done, because this is just what we don't want. Especially whereby after all the effort, somebody will not be able to answer questions from what has been discussed. Okay. So real numbers are numbers, okay? Real numbers are numbers that are significant, okay? Numbers that exist, numbers that has value, okay? That is all you call real numbers, all right? And of course, the opposite of real numbers are called what? Who can tell me? The opposite of real numbers. Hello, is it that we're not hearing me or we just want to be quiet? The opposite of real numbers, I thought was last time, actually means imaginary numbers. Okay, so when numbers are not real, they are imaginary. Please, I don't want my efforts to be in vain. Please, let's be responding. Okay, think network is, yeah. So the opposite of real numbers are imaginary numbers. When numbers are not real, then they are imaginary. So these are numbers that can be measured, real numbers. So numbers are numbers that can be measured, um, on continuous one-dimensional quantities. You can use real numbers to measure distance. You can use real numbers to measure duration. You can use real numbers to measure temperature. Okay. So it is a union of both rational and irrational numbers. Okay, and that will take us to what we're going to be doing today. I told us that last time, towards the end of the class, that real numbers are divided into two broad parts, that's rational numbers and irrational numbers. And you can see that in this diagram down here. So you have on this you have on the diagram. So on this diagram you can see real numbers. I believe you can see it clearly. This one, the biggest circle you can see here, real numbers, and you can see imaginary numbers out in another circle, which is this one here. So, and then when you have both imaginary and real numbers together, complex number is formed. Okay, that's the intersection between the two. Then under the real numbers, you have rational numbers and of course irrational numbers. So this one here are are rational numbers. Okay, see rational numbers. So under rational numbers, every letter that follow. Then every number that is not a rational number will definitely be irrational. Now, going straight to rational numbers, which will be our first discussion and first point of contact for today. We have already seen that rational numbers are one half of what real numbers entails. Okay, so they are part of real numbers. So how do we know them? Rational numbers are those numbers which are those rational numbers are those real numbers which can be expressed as ratio of two integers. Okay, we have not done integers, so let me not deviate and start talking about it now. But real numbers must have two integers. Hello? Hello? Okay. Please, can we hear me? Okay, rational and irrational numbers both make up real numbers. Now, a rational number is one number that can be represented, as a ratio of two integers. That is to say, it can take the form P over Q. And of course, both P and Q are integers. So any number that you can express in this form. So if you have a number like 1 over 2, You have a number like 2/5. So these numbers are rational numbers. 7/1, 1/3. Can you give me more examples, please? More examples of rational numbers. More examples of rational numbers. Can we hear me?
Let me take those shoes. Your feet must be tired. Here's some special.
Yes, you're live. You can speak up. Tell me, I need more examples of rational numbers. Please, if you are not going to be answering the question, mute yourself. Don't we have any examples to share? Okay. Let me move on now. I'm just doing all this so I will know when I network disconnect me. This one are not responding. Accordingly, we have a number here, Q. So Q is the way of denoting rational numbers, just as we have capital R, okay, as the way of denoting real numbers. So we use Q to denote rational numbers. So if you want to as a set, the kind of we call this type of set denotation what? Can anybody tell me? When with this set notation?
What did you say, sir?
I said set notation. We have this. They said Q, which is what rational numbers, is equals to X. Okay, such that X is equals to P over Q, and P is an element of what? Z. Z means what? Integers. Okay, and of course, Q is an element of Z. Z means integers. So, what form of set notation is this? That's set builder. Set builder with set builder. Then we have tabular or rooster method. Hello? Do we remember that? So what they're saying here is that what when you have rational numbers, any number that you can express in such a way that it has denominator and it has denominator, you have numerator and denominator, that is to say you can express them as a fraction, then that number is what? A rational number. Okay. Now here they say that what? Each integer is also a rational number, since, for example, 5 whole number is the same thing as what? 5/1. Okay, that makes it a what? Rational number. All right. 3 whole number means 3/1. So every whole numbers, okay, every number that has no decimal, you can express them as what? Fraction by giving it by giving 1 to it as a denominator. Now, a rational numbers or a rational number is closed, okay, not only under operation of addition, multiplication, and subtraction, but also under the operation of division, except by 0. So what I'm saying here is that the sum, product, differences, and quotient, except by 0, of two rational numbers is again a rational number. So when you add two rational numbers together, subtract or divide them, you're going to get rational numbers as well. Okay. Yes, your answer is going to be a rational number. So let us have an example here. You have so let's use 2 whole number, which is a rational number. Why is it a rational number? Because 2/1 is possible to express it as 2/1, which gives us what? A fraction. Okay. Now 2 plus another rational number. Let me use something like 1/4. 1/4. Okay. So if I'm to add this, I could do it this way. 2 over 1 plus 4 times 1 is 4 plus 1, 5. I'll change this one to improper fraction. I can do it this way then and solve. I can just go straight and say 2 plus 1 is equals to 3. And then 1/4. You can say LCM of 4 and 1 is 4. Sorry. So 1 in 4 is 4. 4 times 2, 8. Plus 4 here, 1. 1 times 5, 5. 8 plus 5 is 13. 13 over 4, which is equals to 4 in 13 is what? 3, right? Remainder 1 over 4. So my answer is what? 3 1/4. And this 3 1/4 is also a what? Rational number. You can see that I was able to express it in this form. So when you add two rational numbers together, you will get rational numbers. So that's what they mean by it is closed under the operation of addition. So you can try out the remaining one, pick any two rational numbers, multiply them, subtract them, and then see the answer is going to give you. So these are sets of rational numbers. Look at them. 4 over 7, 1, 4 over 3, 2 whole number, 8 over 9, 12 whole number, 7 over 16, 2 over 3 whole number, 32 over 129. Then we have negative. So rational numbers has positive and negative as well. Okay. So the positive are usually on the right side of the line. Okay. When when we are doing real numbers, I introduced us to number line. Okay, so negative we have minus. Positive does not have a minus in front of them. So that's that for real numbers. Do you have any question?
Can you solve the
Do we
maths
have any
again, please?
question? Please, if you have any question, you can speak up.
Hello, the boss.
Yes.
I don't know if everybody understand the what you just did, do, as in the solving of that um, uh, rational numbers, right?
Yes.
Can you follow it again? As in, can you do it again, please?
What am I doing again? What am I to do again, please?
The solving that you just did on the sheet.
That's just that is I just try to explain something that
Oh,
rational
okay.
numbers are close under addition. So they are close under addition. When they are close under addition, that means adding two rational numbers will still give you a rational number. And I try to prove it that
Prove
yes,
it. Oh,
when
okay.
I add two rational numbers together, the answer is also going to be a rational number. Nothing more,
Mm.
nothing less.
Okay, thank you.
You're welcome. Any other question?
Yes, the boss. It's like what I'm seeing on the screen is different from what I have in my course material. These examples are not in our course material.
What examples are in the course material, please?
So this is the example I'm looking at in the screen now.
And
This.
those they are not. I got extra examples in order
Oh,
to aid our understanding.
okay, okay.
Thank you. Any other question?
If we are there, may I ask question now?
Okay, so if we are not asking questions, does it mean we understand how to move on to the next one?
Hmm.
When we
Okay.
get to rational numbers, we still need to, you know. Hello?
You're live. Oh.
Okay, so that is that for rational numbers. The next one is integers. Integers are real numbers. Okay. Yes, because we know that every number is a real number except imaginary number. Okay. So integers are real numbers and we have examples. So these ones do not take negatives. That's a negative. They do not take decimals. They can be positive, they can be negative, but they don't have decimal parts. Okay. So we denote them by Z. Integers is Z. Real numbers is rational numbers is Q. Don't forget, and then the real numbers is R, capital R. If you remember very well, I told us when we are working on set that when you see capital letters tells you the name of the set. Okay, while small letters is used to represent the elements. Okay, so integers are a set of counting numbers. It can be positive and negative along with zero. They can be written without a fractional component. Okay, they can be written without a fractional component. One important property of integers is that they are closed under operations of addition, multiplication, and subtraction. That is the sum product and
Yes,
differences of
division.
integers again is an integer. Okay. We are going to work on that and see it. Now notice that the quotient of two integers need not be an integer. Hence, they are not close under operation of division. I'm going to also explain that one. So let's just quickly look at integer number line. So this is what integer number line looks like. You can see that unlike real number line and rational number line, there is no decimal parts to it. It's just figures that are complete by themselves, both the negative, the positive, and of course the origin, which is 0. Is it clear?
Yeah.
So if you have numbers like you have numbers like 1, numbers like 11, okay, numbers like 250, even their negatives as well, like -15, -13, etc. They are all under what? Integers. Is that clear?
Yes.
Yes.
Yes, you're live. Yes, I'm listening.
Yeah, answering your question, you asked if it was clear, and they answered yes.
Okay, please can we send me Mr. Okay, can you send me the forward this to me? This timetable, forward it to my DM, please. Thank you. Okay. So now let's now work on what we have here. They told us that they are closed under these different operations. So let's check that out. Now we're going to start with addition. Okay, we're going to start with addition. Now in addition, we're going to pick two integers. So the two integers we're going to pick, we can pick integers that are whether they are negative or positive, it doesn't really matter. Okay, so we can pick something like this. We can pick 2.5 and then plus, let me not use plus again, let me use minus 2.04. Okay, so when we subtract it, what will be the answer? Oh, I'm sorry. These are not integers. Integers can be, okay, we just pick 12. 12 minus 6. What will be the answer?
6.
What will be the answer?
6.
Okay, thank you. 6. So is 6 not an integer?
Yes.
6 is yeah, 6 is an integer. If you have something like -3 plus 4, what will be the answer?
-1.
Huh?
-1.
Yes, I'm listening.
-1.
-1. -1.
-1. How is it -1, please? Can you explain? How do you get the answer, sir? How did you get your answer?
Okay, well, I think since -3.
Okay, so the answer is 1, not -1. Okay. Let's work it out on the number line. So you have something like this. And then -3. Since it is plus, you know it's going to go this direction towards your right hand side. So you can start your -3 as the first figure here. And then you have -2, -1, -1, 0, 1, 1, 2, 3, and so on and so forth. Now, since I want to do -3 plus 4, I'll come to -3. I'll move 4 places to the right because it is plus. If it was minus, I'll move towards the left. So I'll come here. 1, 2, 3, 4. So you can see that -3 plus 4 is worth 1. -3 means that I am owing 3 naira, for instance, and they pay me salary of 4 naira. I can now pay my debt. So after paying my debt, what we left? 1. So the answer is 1. Anyway, whatever the answer may be, what I want you to know is that this one is also an integer. So you can see that even when you multiply, 12 times 6 gives us 72. That's an integer. -3 times 4 gives us -12. That's an integer. So I think that explains all that we have here. Do we have any question as per anything that you can see concerning this particular type of sets? Do we have any question? Since this is not a physical meeting, our feedback goes a long way to help me as a tutor. to know if we are on the same page. So that's why I stop every now and then to ask us if we are flowing and stuff like that. And when we don't give any response, it makes it a bit difficult. So even if you cannot speak, you can always type, okay? So that I'll know that yes, I'm communicating. Okay. Now let's move to the next one, which is whole numbers. Whole numbers. Whole numbers. Now whole numbers is kind of similar but different from integers. Now remember this figure here. So under real numbers, you can see rational and irrational. So under rational, you have integers, which we have done. Now we are at whole numbers. So that means every element that you have under whole numbers are integers. So all whole numbers are integers. All integers are rational numbers. All rational numbers are what? Real numbers. Do we understand?
Yeah,
You don't understand or what? Okay, now whole numbers are part of the number system, which includes all the positive integers from 0 to infinity. So integers starting from 0, 1, 2, 3, and above are all whole numbers. The negative integers do not make up whole numbers. So we can say that whole numbers are real numbers, but not all real numbers are whole numbers. Because we have real numbers that are negative.
The boss, I can't find the whole number
Hello?
of the material.
Hello, I can't hear what you're saying.
I can't find the whole number on the course material. I'm looking for it since.
Yeah, it's not the course material, but it's part of it.
Jesus.
They did not give it a subheading, but it is embedded in the amongst them. So I had to pick it out so that I can be able to discuss them one after the other. So whole number is there. They denote it with W. It's part of the number system, numbers of part of set of numbers. So
The boss.
away from that,
Hello, the boss.
yes, I can hear you.
One cannot actually take screenshots of the facilitation, so that one can always go back to it. For example, now I can't be able to write all this thing that you have, all this thing I'm seeing now. I can't write it before you move on. I don't know if you understand.
So what should I do?
I believe it's a setting on the it's a setting on the Telegram. It's not allowing us to take screenshots.
I don't know. Maybe you have to update your portal, your own platform. You have to update it from your side. I don't know. I don't know any setting like that. All I know is that I teach my classes.
All right.
I don't know anything about screenshotting. I think screenshotting is something that has to do with device. Does it have anything to do with the software you're using?
It is only when I'm on Instagram. I say Instagram, Telegram, that I can't take screenshots. Maybe somebody else should try it and see.
It's not only you, even me, sir. I tried doing screenshot, it's not working.
So I'm not alone.
This way.
Okay.
Then you have to pay attention. Then you have to pay attention and pick up everything then.
Pick
on the
up
class.
everything. Amen.
Yes, now.
Yeah,
Pick up
Mathematics
yeah,
class.
everything then.
Okay,
I
amen.
can do a
All right, sir.
screenshot too.
Hello, can you hear me?
Yeah, I can hear you. I can do a screenshot. I just did
How?
one now.
So that means it's from your end. It's not
I think
from.
I think
It's.
I
I think.
think I think it's from your device, or maybe your Telegram app is not updated yet.
Eh, okay.
Because
That
I
is.
just did two of
See how he
your
was just talking. You know, see how the guy he was talking. I was accusing me as if there is a set. I was just wondering. Egbami o.
No, I need to ask now. I need to ask because I've tried
I
it so
just
many
I just
times.
did, I just did two of his screenshot now.
Wow, congratulations, sir.
It's saying my own screenshot due to security
Maybe it's
policy.
your
So
phone.
I
Maybe
don't
you
know.
should get a higher phone. Maybe that is why.
I'm using a high
Me, I
phone.
put
Oh.
it in
I'm
the
using
phone.
what do they call them? The
Go and
newest
get
version.
iPhone. Go and get iPhone. iPhone
iPhone.
14.
Eh?
Uh,
How
Get
do you
iPhone.
want to pay school fees?
Ma?
How do you want us to pay school fees when you are using iPhone 14?
People are using iPhone 14 and not paying school fees. Be deceiving yourself. Go and get iPhone. In fact, iPhone, you can even you will do your business. Your business itself, it will help your business to grow. You make money. They use that phone. That phone is a phone that sells market. It's not just for fashion. It's not for fancy. Okay. I'm not the iPhone I'm using self. I know the kind of transaction it has helped me to if I have money now, once I want next thing I'm targeting. That's why I told everybody, yeah, subscribe for my classes. If I'm not subscribed, only if people are subscribed. Subscribe so I can go and get iPhone 14. I beg. I can't shout. Once you get the phone, it will help you. If you want to do video for your products, want to do anything, it will be very, very okay. Like, I don't need, let me not start marketing them because they're not paying me for marketing. So let me not market their product, but go and get iPhone. I think if you have iPhone, most of these things we are complaining, not be complaining about it. I be not be so. So so before we continue the class, I was saying something about whole numbers. So whole numbers are positive real numbers, positive integers, okay? Yes, zero and then positive integers. Can we all mute ourselves, please? So positive, these are what positive integers and zero make up whole numbers. Okay. So we want to start from 0, 0, 1, 2, 3, and so on and so forth. They are all real whole number, not real number, whole numbers. Okay. So here now, this one that we have here, this minus 1 is not part of it though. Whole number, that is integers. Whole numbers will start from 0 and above. Then we have natural numbers. Okay. We have natural numbers. So natural numbers are positive integers. Okay. So natural numbers are what? Are positive integers. That is to say, when you have whole numbers, okay, remove 0 from it. So we have 1, 2, 3, okay. That's when you have natural numbers. Is that clear? Is that clear? Do we understand?
Yes.
So if there's anyone you don't understand so far, I can ask your question before we move on to the next. Yes, I'm waiting for our response. Now, when we say subset means that every element in this particular set is an element of this. Every element every element that is a set of this is also found here. Every element of this is found here. So natural numbers are under integers. That means all natural numbers are integers. Integers are under rational numbers. That means all integers are rational numbers, and all rational numbers are real numbers. Okay. Natural numbers are closed under the operation of addition and multiplication. So anytime they say this close means that when you perform any operation with two of those numbers, it will give you the same type of number. So in this case, they ask a lot of questions, TMA and exams under this with this rule. So you need to know them very well, okay? For all of the types of all the set of numbers, each one of them from real numbers, under which operation are they closed? For rational numbers, under which operation are they closed, and so on and so forth. So when it comes to rational numbers, they are only closed under addition and multiplication. That means if you have two natural numbers, you add them together, your answer will be a natural number. If you have two natural numbers and you multiply them, your answer will still be a natural number. But when you subtract two natural numbers, you may not get a natural number. If I say 5 minus 10, 5 and 10 are both natural numbers, and I'm performing subtraction on them, I'm going to get minus 5. Minus 5 is not a natural number, so it's not closed. If I say division, okay, I can divide 5 by 2. When I do that, I get 2.5. Okay, 5 and 2 are both natural numbers, but 2.5 is not a natural number. So you can see that the operation is not closed under division and subtraction. Now, the last one I will be taking us for today is the irrational numbers. Okay, so the irrational numbers is another branch of rational numbers. Please remember, we said that we have rational numbers. And under rational numbers, we have irrational and, sorry, we have real numbers. Don't get it twisted. We have real. Okay, so under real, we have rational. Rational is denoted with what? Who can tell me? So real is denoted with R. Let me just use the annotation. So real is R. So rational is what, please? Rational is related with what? Who can tell me?
Q.
Yeah, God bless you. Q. And then irrational.
It's still
So
Q, but has apostrophe, whatever.
yeah, that's Q complement.
Yeah.
So you can use Q complement. You can also use P. Yeah,
Okay.
you can also use P. But let's leave it as Q complement.
Okay.
So then under this, okay, you are now having Z, which is integers. We are now having W, which is whole numbers. You are now having N, which is natural numbers. Of course, natural numbers has two parts. It has prime numbers, which is small p, prime numbers, and the composite numbers. I think this one is small. I think. So prime and composite numbers. Now, if you want to tell the difference between um, these two,
Okay.
there is need for you to understand decimals. Okay, there is need for you to understand decimals. Decimal fraction. So we have how many types of decimal? How many types of decimals do we have? Yeah, who can tell us how many types of decimals do we have? Can somebody attempt?
Okay, we have just three types of decimal.
Okay. So what are they? Yeah, what are the types of decimals that we have?
Okay, non-recurring and recurring decimal, I think,
I'm listening. Harry, recurring decimal. What should I want again?
and non-recurring decimal.
All right, but you said we have three. So what's the third one?
Sorry, two.
Okay, you two. All right, sir. You tried. But there are more.
Okay.
Abina, since you said it's three, there should be more. Let me come in. So we have recurring and non-recurring. Okay, fine. Now if you want to describe decimal, you have to there are three basic types. Okay. We have there are two basic types of um decimals, but if you classify it properly, you see that there are three. So we have what they call the terminating decimal and we have non-terminating decimal. Okay. So under the we have under the terminating and then non-terminating. Now, under that non-terminating, we have what they called non-terminating reoccurring. Okay, non-terminating reoccurring, and we also have what non-terminating non-reoccurring. So we have terminating decimal, which is the first one, okay, and then we have non-terminating. So when you say we have reoccurring and non-reoccurring, that means we only can only have reoccurring and non-reoccurring decimal under non-terminating. What about the what? The terminating. So essentially, you can say we have three types of decimal. Okay, that is what the terminating decimal, the reoccurring non-terminating decimal, and the what? The non-occurring non-terminating decimal. Do you understand?
Yes, thank you so much, sir.
So let us now look at the example. Okay. The example, just give me a few seconds. I'm coming. All right. So I'm back. All right. So I'm talking about the terminating decimal. So terminating decimal are the normal decimal that you have. So terminating decimal are the normal decimal that we have, like 5.2, 3.4. You know, all those are what you call terminating decimal. Okay. Then we have others like 3.42, 5.15, right? All those things are what you call they are terminating. Okay, fine. Now, the non-terminating decimals are the ones that does not have an end. For example, if you say 4.42222222, 3.16666, 4 point, just kind of decimals, they are non-terminating. Okay, they continue. Sometimes you need to approximate them. Okay, maybe to 2 decimal places, 3 decimal places, and so on, in order for you to put an end to it. Okay, that is what non-terminating. Now, those non-terminating decimal, there are some of them that are recurring. When they say recurring, it means that the same number is going to be appearing over and over. So you can have 0.33333333. That is a what? Is a non-terminating. Can we hear me, please?
Yes.
So that is a what? Is a non-terminating reoccurring, because the same figure is coming up over and over again. Then the other one that we are having, then the other one that we looked at or talked about is what? Non-terminating, non-reoccurring. So these ones too, they're just like the other one that we saw. They are long and doesn't end, but the figures are changing. Unlike in the other one where you just have maybe 0.6666666, 2.444444. This one changes. You can have 1.67845, different figures, all right, coming up. That's what non-terminating, non-recurring. Now, for you to be able, why am I saying all these things? We want to be able to differentiate between the what? The rational and the irrational numbers. Okay. So the irrational numbers now are those ones that falls within the non-terminating, non-reoccurring. The decimals that are what both terminating and non-terminating reoccurring are all rational numbers. Okay, so we have here decimals, and we have seen that we have three. We have terminating decimal. Okay, terminating decimal. Okay, and then we have the second one, non-terminating reoccurring, non-terminating reoccurring. Let me just reoccurring. And then we have non-terminating, non-reoccurring. So these first two, terminating and then non-terminating reoccurring, falls under what? They are both rational. Okay, and these ones are irrational. So for example, we have let me say we have 0.6. Okay, this is a what? Is a terminating decimal. You can express it as a fraction, and it will become what? 6/10. Okay, so the fact that you can express it in this form makes it a rational number. 0.333333333. I have 0.3. So on and so forth. It continues. Okay, I can express it as 33/100. Okay, so this actually makes this class of decimals qualify as this can actually qualify, makes it possible for you to classify them as what? Rational numbers. Now for the irrational numbers, someone is saying you cannot see my screen. Is that true? Can we not see my screen? Can we not see my screen?
I can see your screen.
Please, is anyone not seeing my screen? I want to know.
I can see your screen, no.
Okay, thank you, no problem. Okay.
When's your
So, sir, you can work on your end. Maybe there is an issue from your side. Like, okay, maybe your network. You need to like log out and log in again. So now, non-terminating, non-recurring. Okay. So I'm going to give you some examples, and these are here. So you have this now. You have square root of 3. If you have a scientific calculator, you can calculate it. Check out the square root of 3. Tell us what comes out. Oh yeah. If you have scientific calculator close to you, work it out, work it out, work it out. If you have a scientific calculator with you, square root of 3.
One 1.73205080
it's one.
75. So
Continue.
2.732050 whatever. So we can say 1.8. Happy.
You cannot say. You have to give me what you can give.
1.7.
You have to give us
Now
everything.
we have to put
You got
everything. That's
to.
1.72 0508075688772 93527 446341505872366942.
So you can see that this is a what is a non-terminating decimal, and it's also non-recurring because it's not the same figure we are seeing. You can see 732, you can see 050, you can see 80757. So that's why is a what is an irrational number. Okay. Now we have another one. We have pi. We use this a lot when we are calculating circle. Okay, area of circle, perimeter of circle, and stuff like that. So this is also another one. Okay, so this is approximately, they approximate it to 3.142, but actually it is 3.1415926535897932382383279, so on and so forth. Okay. Then we have square root of 2. Can somebody calculate the square root of 2 for us?
Square root of
1.4142136.
1 point what? 1.4.
Yes.
4
Are you sure you did? I'm not sure you did the right thing. I'm not sure you did the right thing.
Now Google on.
No be Google one. This one a calculator.
Yeah, okay. Well, Google say 1.4142135637. Let's go there.
Yeah. How should I be correct? Okay. It's all right, no problem. No problem.
Help us check it from your end to know maybe we are correct.
Yes, it is 1.41
4
13
5
15
6
5 6 2 3 7 3.
voila.
So it is 1.141 1
1.1
1.4
1.4142.
hello, can we hear me? The square root of 2 is
Yes,
1.41.
1.14.
142
No, not 142. 1.41.
42
Yes. 1356
7.
Yes.
7. It continues, so don't stop there. So it is a what is a non-terminating and a non-recurring decimal. You can see different figures are there. So these are the examples of numbers you call irrational numbers. Okay. So these numbers cannot be presented as fractions. Because of that, you call them irrational numbers. Is that clear?
Yes, it's clear.
So I think we are done. So I'm going to give us exercises. Okay, I'll call numbers out. You tell me where they belong. Are they rational? Are they irrational? Are they real numbers? Are they integers? Can we do that? Can we do that? Are we ready? Nobody's ready. We're running away. We're not ready. You must be ready. Oh, hey, you must be by force, by fire, by thunder. Why shall you not be ready?
Bring it on.
Okay, let's give it a try. We'll just try because
Let's give it a try.
Okay, let me ask us this one. They said, identify whether the following are terminating or non-terminating. So I'll share my board. I'll open my whiteboard now. So this is 3/5. Then we have 3/4. We have 81/25. Eighty-one over 25. We have 1/9.
Who is this person in the kitchen? Oh, you should mute, please.
So let me stop here. Okay. So these 4 figures I penned down. I want us to tell me, where do they categorize? Are we going to call them rational, irrational with reasons? Tell me.
Okay, it's a rational number. That 3/5. It's a rational number, and my reasons for saying that is that it's 3 and 5. They are from 2 integers.
Oh. Is it by that one? Have you calculated it and see that it is not non-terminating, non-recurring?
Okay. Okay.
Can be divided, it's an irrational number. It's an irrational number. See the numbers.
Someone else can try. You tell us.
Most language. You say to most language. No, too much.
Somebody else should try you.
What happened to you? Are you not somebody?
I am somebody. I'm coming.
You also say it's not does not recall. Like this one is rational. Can recall.
Okay, Mr. Teacher, I mean lecturer. That's 3/5, it's a rational number because when I did the calculation, it's giving me 0.6. So it's from two integers, 3.5. They are fractions. So that's just my own this thing. But I've not done the rest. But that 3/5 is from a rational number. It's
No, all the rest rational. No, the ones that cannot reoccur. The rational are those ones that reoccur. Like when you divide, they still give you that same number over and over. Mhm.
Oh, you're live. Please, can you come back with what you said? I was attending to something out here.
Timile, you come back, please.
okay. With my own calculation here, what I said is that 3/5 is giving me 0.6, and I guess they are they are rational numbers and they are two different integers because it's a fraction number.
Okay, accepted. It's irrational numbers because it is a what is a terminating decimal. All right.
Okay.
The next one. When you convert to decimal you're going to get is a terminating decimal. 0.6 is terminating decimal. Oh, that settles it. Okay, next person, next question.
Sister Adejoke, where are you?
So the next one, I will soon be ending the class so that we can continue talking on the group. I've sent some questions there. Okay. 3/4. 3/4 is a terminate. When you work when you calculate it, you're going to give you 0.75. Okay. So when you convert it to decimal, it will give you 0.75. And 0.75 is a terminating decimal. So that's a rational number. Then the other one is what? 81/25. When you convert it to decimal, what are you going to have? You should be having 3.24. And that is what? That is a terminating decimal. So it's a rational number. The other one, 1/9, convert to decimal. You'll be getting 0.111111111. That's a what? Non-terminating but reoccurring. Non-terminating reoccurring decimal. So since this is a non-terminating but is reoccurring, it's going to be a rational number. So everything you can see on your screen are all rational numbers. Do we have any question, please?
Okay, please. I just want to ask that. Please, can you share us your own like your guidelines that you're using to teach us? Can you just please share it with us so we can, because it's not on our materials, so we can also just add it. And
those that subscribe for my classes, they are having it. They have access to all those things. You not subscribe. Most of you not subscribe. Just see link. You just come for free class now. You're coming for free things. So
Okay, how much is the class?
that's
Sorry, don't be annoyed.
yeah. Subscribe. Bring the money first. Which one is? Have I not tried? I come on teach class again. I come on
The boss is asking of the money. Maybe you should private chat you.
He's
Okay, no
asking
problem.
which private chat. Let's talk. Please, the money. Account number will be sent to the comment section. Send the money to
He
the
doesn't
account
know
number.
the
There's
amount,
nothing.
so he doesn't know the amount.
The amount.
The actual fee.
The amount is
Yes.
everywhere now. I've told her for the beginning of the semester. Management sciences 10,000 only. Only. So please send it. I'm going to draw the account number on the comment section. Don't let me carry second because this very economy. Let me see something to use and eat. I beg.
Okay.
What's
Why is
funny? Is it
Timileyin
funny? It's
laughing
not
for
funny
crying?
at
I
all.
don't know. Why are you laughing?
I don't even understand what's funny. This body economy is no longer funny. Saturday should come. Let's someone go and vote. So please let's vote on Saturday, please. So we should not. This must not continue.
I'm not voting.
All
No.
right. So on WhatsApp, I'm going to drop the questions question for us to answer. I will share the slide with us. Then once we are there's still some things we need to do. So once I'm done with the slide, I will share it with us. So every one of us we can use it for our own personal studies to complement the course material. So that one is that. And in our next class we'll try to tidy this up. We have started function. For those that missed out, I think the video, I think I've uploaded it. I'll check if I uploaded the recordings so we can go there. If you have not subscribed to my YouTube channel, go and subscribe so that once we post any replay, you can catch up. Subscribe and share my link so that people can come in. I need thousands of subscribers. How will I be having on my contact alone? I have over 15,000 contacts. They should also come on my YouTube channel. They're speaking English. I don't understand. You guys should go and subscribe to my YouTube channel. Then my channel, let me have enough subscribers on that channel. At least from that one, so someone will be getting money. Because if you have more subscribers and engagement on your platform, YouTube will be paying you. This one I'm telling you, pay subscription fee. Some of you are looking at my faces. At least if it's $1,000 or $2,000 I'm getting from YouTube once in a while, let me use that, be holding myself, at least for my effort and for my time. So go and subscribe, share the link to your friends, tell them to come and subscribe to that channel. It's a very, very good channel to subscribe to. That is why I post the replays. Any replay that has to do with video, I post it there. And we also go live on that platform. Yes, you are live.
Good evening. Please, what's your YouTube channel?
My name is YouTube channel Okadike Stewart. Okadike Stewart. In fact, the link I'll drop the link on the comment section. If you are subscribed to this particular platform, you will see the link. And on WhatsApp, you should help me and share it. Share it to your friends, share it to a group, and follow them up. Follow them up to they subscribe. They should subscribe, please. At least before the end of the day, I should get 2,000 subscribers just this evening. Hey, Joe, let me sell.
The boss.
Yes, you're live.
I think you should go an extra mile by lose your contact by speaking to them maybe one-on-one so that they will do the needful. Sometimes
I can't even hear what you're saying.
Can you reach them one-on-one so that they can be able to do the needful ASAP? As in, go to the YouTube channel and follow the.
I've chatted people one-on-one. I've broadcasted the message. I've followed them
up. It doesn't
take
anything from anybody, It's just for you to just click on the subscribe, and that's all.
Most people don't really. If they see link, they might not really be eager. They might think that maybe it's a scam link or something. So people are very, very careful. So it is people that have been there that knows the person very, very well. That can be able to convince them. And for me, I'm too busy.
Those your pals. Those your pals. Those your close friends. Are all of them there?
This one, most people that should be there are those that are like maybe students of now.
Okay,
I created a platform, so I'm not sending the link to my own friends. Except if I have a program I want to hold on that platform, and I know that majority of them, like what I'm saying is that I have people outside now but I have other platform. I have other channels that I connect with them with. So that's one I created it specifically to address educational issues. Okay, to reach out to students of the school and other people that might have interest in some of the content I post there. So if I know someone that may not really have any need for what I'm posting there, why should I be sending link to them? So like in my church now, not all of them are students. Okay, most of them are businessmen and women that are not even dreaming of going to school. So what would they want to be doing on that kind of platform? So I don't share the link to that. I share link to because I don't want to have group a platform that I will have so many subscribers and yeah they're not engaging, they're not watching the video. What actually matters most is for them to watch the video, like, comment, and stuff like that on the video, so that the video can, the ranking of those videos can be, high up there, and then of course, then with that, I can be able to be getting, a lot of my watch hour will be growing, and I'll be able to be getting, when the time for when I get enough subscribers for them to start paying me, I can be getting enough money. So if I have subscribers that do not really need the platform, what are they going to be? Why would they be there? I'll just be posting last, so nobody will watch, nobody will be doing anything there. So I just want to be sure that I'm targeting those that need the platform.
The right,
So by the time
the right
by the time
audience.
yes, the right audience, that is just it. So maybe when later, if I want to do general maybe program or something that I know that anybody can join, like I want to just talk about maybe regular things that happen in everyday life, that's one I can now make it public. Everybody can join. But for now, I'm just trying to target. I just want to build my niche around those students that are going to be needing the content I'm posting there. So that is why I'm not really posting it to my personal friends. I'm just posting it to my clients, my customers. Okay. So all of you are my customers. So you guys should go and subscribe.
No
Subscribe
problem.
and then you share. You share it to all those your friends that is in school. Send to them on their DM. Tell them, oh yeah, subscribe. I want to see your subscription. And then they should tell you they are subscribed. They will send it to you. You will see
The
subscribe.
boss.
And then tell them, forward to your friends of your friends of your friends of your friend. Before
Please,
9
I have a
p.m. today.
question. No.
Wait, now let me talk more. Let me talk business. Well, wait, let me talk my own. Let me talk my own first. Before 9 p.m. today, I want to open that channel and see 2,000 likes. Let me dance. In fact, I'll go live. I'll dance for you people very well. Please subscribe. What is all this now? See, my phone just full. Students everywhere, different groups, and I will have channel. People that don't even have channel, that don't have enough audience like me. Their own channel, thousands of followers, thousands of like my own channel. I'll be seeing.
You see what?
The boss, you'll get there. Don't worry.
Please, so everybody, I'm the new student too, 100 level accounting. So I want to ask, is it always taking all accounting courses or just only math?
That is why you need to private chat him. Private chat him. You
Okay.
understand? Do you have his contact?
No.
Is the boss still there?
I think he has network
Network issue.
issues.
Okay, maybe I should just throw it to the floor. I discovered that the e-learning platform is still having last semester's courses. So I don't know if we are all having the same thing on our platform.
Yeah, I have not really checked, but me, I want to wait till the kickstart of TMA. That is when I will really look there
You know
because
why I'm asking? Because even the facilitation is most of them will, you get some of their schedule and all those stuff on it.
no, you can you will get it from there. Then
Mm-hmm.
they will be sending you
Mail, yeah.
mail as well. Yes.
Mm-hmm.
Mm.
Well, I
Me,
don't know. The one
I just have to wait till the TMA. TMA is opening by 4th of May, right? 4th of March.
much.
4th of March. So I'm just waiting till then.
Okay,
Sorry,
maybe
we
by
that we are
then
not having issues. We that we are having issues with our team e-learning portal. What are we going to do?
What type of issues?
We can't log in, as in it's writing error with our matric number.
See, you keep trying. It's network issues.
Okay.
Yes, but if the
Yeah.
kids persisting, I would advise you go to the school because I remember when I put in last year, I had that same problem. So I had to go back to my what they call it center and
The
to
yeah,
the IT,
the IT guys there.
yeah, to rectify it.
Okay. Thank you.
Hello, can we hear me?
Boss, welcome back. Oh.
Boss, you're alive. It's not live here too. I think this class is over.
Is this class over?